Hello, my dear friends. So it's me, Rajababu. In this video, we are going to see a simple application of a moisture sensor and Arduino. In our previous videos, we have seen how to interface digital sensors and analog sensors with Arduino. Now let us make some applications based on the knowledge which we gained in our previous videos. So this analog sensor, that is a moisture sensor, is one of the simplest one and much useful one. Okay, so let us start up with what is there inside and why we need this project, everything. So what is the objective of this project? This project is to feed the plants required amount of water at required time, so that at your presence or when you are not available in your place, still the plants will get the water what it needs. So what we are going to use for achieving this task are very simple things, like we are going to use Arduino Uno moisture sensor and one some relay module and a pump. Okay, so if you want to make the system to be powered by the solar, then we can use solar module and related items. So in this video I am going to show both of them. Okay, so these are the components which I have used. Arduino Uno moisture sensor, I have used one 5-volt relay module, then 12-volt water pump, then I have 12-volt 100 ampere battery, 100 ampere hour battery, and 200 watts 24-volt solar panel. It's a standalone system. It does not need any supply from the company, the distribution company. So it will work even when the power cut or whatever is there in your place, still it can do the work. Charge controller and isolator. So let us go one by one. So the main component of this, the whole process, is a soil moisture sensor. So there are two type of moisture sensors available in the market. One is based on the resistive principle and another one is based on capacitive principle. So resistive principle, it is very simple. It will have two electrodes. From one electrode the current will be passed, and the current which is passed in the electrode will pass through the soil. So if the soil carries more moisture, then that means the conductivity will be high, or you can say in the vice versa case, the resistance will be low, so that the current flow will be taking place, and it will reach the second you can see here, like one probe here, the another probe here. The current will be passing from one probe and it will pass through the soil. Okay, so where you want to measure the moisture level. So based on the moisture content, the resistance offered for this electricity flow will be varying. And if the if the soil is very much dry, the resistance will be high, and in vice versa case, and this current will go back in the another probe. So this resistance offered for the electrical flow will be measured in this module. Okay, so there is one more module here, and that will be interfaced with our Arduino. So the resistance offered by this soil will be measured. Based on that, we can take a decision when to switch on the pump and when to switch off the pump. And the second one is a capacitive soil moisture sensor. Again, here we have two plates. For a capacitor we need two plates and one dielectric medium. Here in this capacitive sensor, two plates will be offered and the soil will act as a dielectric medium. Okay, so based on the water content in the dielectric medium or the soil, so the dielectric medium conducting property will change and the capacitance will change. So this will be calibrated and the output will be taken to the Arduino, and the Arduino will do the remaining work. So these are the basic principles of soil moisture sensor. Now let us see the picture, overall view of the picture, So this is the overall view where I have a Arduino. Okay, so this is our Arduino, and I have a relay driver circuit. Okay, so I have a relay here. So this is a relay driver circuit. Okay, so this is my relay driver circuit, and this is my Arduino. And here I have the probes what I have told. So I have a two probe system here, and then I supply the electrical signal here, and I receive back the signal back to this module, and then from this module you will get the input to the analog pin. Okay, so this will be used as a moisture sensing element. And I have a pump. Okay, based on the moisture content of the soil, I can switch on or switch off the pump. So the pump is connected with the tank, and from the tank the water will be taken to the pump, and from the pump it will go to the field where you want to maintain the water content or moisture content. And one more thing which I have added here is a ultrasonic sensor. Okay, so you can have any level sensor. Okay, either it may be digital sensors or capacitive sensors, analog sensors. Analog sensors are different type available, water level measuring sensors. So I have used a simple ultrasonic sensor. So based on the level of water, so I can measure the distance. Okay, I can measure the distance here, how much distance is there between the water and this one. So based on that I can say whether the water is available or it's a over. Okay, so this distance I can measure. So based on the distance I can say whether the liquid is there in the tank or not. Okay, so based on that I can, if the water is there and the field is dry, I can switch on the pump. If the water in the tank is empty, if it is not there, water is not there, even it is dry here, I cannot switch on the pump. Without water, switch on the pump is of no use. Okay, I can give some indication that water is not there in the tank. Okay, so that is the purpose of having this ultrasonic sensor. And the relay driver, obviously you cannot connect the pump directly to the Arduino, because Arduino cannot drive the pump, even though it is a small pump only, but it cannot drive directly. So I need a relay driver separately for this. And then from the relay the battery voltage will be taken to this pump. Okay, so if I have shown here battery, but suppose if you want to make this system automatic and then self-powered. Okay, self-powered means we will not use any utility power from the power supply board. So in that case, what we can do, you can replace this 12 volt battery symbol. If of course you need a battery, but this battery we will be connecting to the charging unit, and the charging unit will be connected to the solar panel. So that is what you can see here. So I have a system where I have a solar panel here, and I have a DC isolator. Okay, and from this solar panel, so you know that when the light is falling on the solar panel, it will produce the electricity, and the electricity will be whatever the voltage is produced here, it will go to this isolator. So isolator is to it's like a switch only, the main switch to open and close the circuit. It is not a MCB, it is only a isolator, DC isolator, to just control the current flow, to just to open and close. It will not have any regulation, but it will just help to open and close the circuit. From here it goes to the charge controller. Okay, so this is a charge controller. I hope you know what is the function of charge controller. So the charge controller will give the constant output voltage to the battery. So this is a 12 volt battery. To charge this 12 volt battery, we need 120 percentage of the capacity of this battery. So that means 12 volt. So if you make 120 percentage, it will come around something 14.5, something like that. Okay, so that is what you are seeing here, 14.4. So this is a thumb rule. Okay, for charging the battery, you need a little more voltage than the rating of this particular battery. Okay, so that is 120 percentage approximately. So From the solar panel, sometimes you get more light and sometimes you may get a less light from the sun. So based on that, the produced output voltage, sometimes it may be more than 16-17 volt, and sometimes it will be lesser than 15-16 voltage. So irrespective of the voltage what is produced here, I need to feed the battery with a constant 14.4 volt. So for that purpose I am using this charge controller. So this charge controller is going to keep the constant voltage flowing to the battery. Okay, so this number of solar panels what you need for charging this battery, it depends upon the size of the battery, and the battery size depends upon how much big pump you are going to use, and the pump size is going to be determined by how much area you need to fill the water. So if the area is big, then the pump will be also big. If the pump is big, then automatically you will have a bigger size of battery here. So when the bigger size battery is here, then what will happen, the solar panel size also will increase. Say for example 100 watts, 200 watts. Okay, so based on the requirement, the panels will be getting increased. Maybe you will need to 2 or 3 solar panels. If it is only a small place and you need to have only less amount of water flow, then that means you need not to buy more solar panels. Okay, so based on the requirement we can choose all these components, right? So let us go to the next one. So this is a Tinkercad simulation what I have done it. So in the Tinkercad there is no moisture sensor available. So I have used a potentiometer. So as I told you little earlier that moisture sensor is a resistive sensor. It is like a variable resistor. Based upon the moisture content, the resistance is going to change. So the same principle like a potentiometer. So I can change the resistance of this potentiometer, so I can calibrate this as a moisture sensor output. So and I have here ultrasonic sensor, so which will measure the level of water. Okay, so with these two inputs I can control the pump. Okay, whether the water is there in the tank and the soil is dry or wet. With these two conditions I can create a logic to operate this relay, so that the relay will drive the motor and the total system will be powered by this solar panel. Okay, so let me check in the Tinkercad. Yeah, so this is the Tinkercad connection. Now let me simulate this one. You can see what happens. For your reference I will take the values for moisture and distance. So the distance is going to say whether the water is full or less. Okay, so if the distance is more, that means the tank is empty. So I will show the picture so that again you can understand. So if the water level, say for example here, if the water level is very low, so that means the distance will be more. Okay, if the water is full, that means the distance between the sensor and the water will be less. So this is one logic. And then the soil moisture content, if the moisture is more, then resistance will be less. So that means when the resistance is high, that means I need to switch on the pump, and I have to see the water also available in the tank. Okay, so these two conditions I am going to keep it for making the program to work. Okay, I will I will show the simulation how it works. So in the this one you can see here. So this is my ultrasonic sensor sensing range. Now, so this ultrasonic sensor is very much related to water in the tank. Okay, so please remember that. So now I move this one, so you can see now the distance, that means the water level in this is decreasing. Okay, the distance between the sensor and the water is increasing, so that means the tank water is getting decreased. And then also you can see here I will minimize this one little. Okay, and also you can see there is a potentiometer which I am using it as a moisture sensor. By varying this, I can see here the moisture content in percentage: 26 percentage, 42 percentage, 60 percentage, 73 percentage, and it is 95 percentage, like that. Okay, so that means when the resistance is increasing, then what happens? It is just vice versa case. Okay, so now I need to write a code with respect to these two inputs what I am getting from the sensors. In the code what I have written here, I'll show you here. The code what I have written, first I have declared echo pin and a trigger pin for this one ultrasonic sensor. So if you are not familiarized with this ultrasonic sensor interfacing, please go through the previous video which I have put it. Okay, so it is very simple again. So these two pins are used for transmitting the ultrasonic signal and receiving the ultrasonic signal. So these two I have declared here, and I declared also a relay. So this I can write anything, pump or whatever it is, no problem. So I have connected the relay output to the 11th pin of this one. And I have declared some variables here. I want to measure the duration, and also I want to measure the distance. The sensor will give only the pulse duration, and I have to convert into distance. And the moisture sensor is connected to A0 pin. Okay, that is analog pin, A0 pin, and then I am declaring one variable called moisture. Now in the setup, so these are the declarations. Then next setup. In the setup what I have done, I have just begin one serial port communication with a 9600 baud rate, and these two pins which I have assigned here, I am just giving it as a whether it is input or output. I need to mention it here. So pin mode trigger pin is the output pin. So that means from the trigger pin, the output signal will be emitted. The ultrasonic signal will be emitted, and in the pin mode, echo pin, it has to receive the signal from the reflected back object. No, when it is reflect back and it is coming back, it has to receive. So it is a input pin. So this is the setup part. Then in the loop, I need to read the values from the moisture sensor. First, I am reading the data from the moisture sensor. So where I have connected moisture sensor, I have connected in A0 pin, analog pin, 0th pin. So what is the syntax for that? Analog read A0. Okay, so this is the content which is coming from moisture sensor, and it is stored in the variable called the moisture. Okay, this you can name it anything. Okay, so I just for understanding I just put it as a moisture. Okay, and then after storing the raw value here, I am just mapping it into percentage 0 to 100 percentage, because this analog sensor will give the variable from 0 to 1023. Okay, so this will give in this format only, but that variable I need to convert into percentage or voltage, whatever the way you want to, you can make it. So since it is a moisture, so I am making it in a percentage 0 to 100 percentage. So if I get a 0 value here, so that means 0 percentage. When I am getting 1023 as a value, so that means 100 percentage you will get here. Okay, and that means when it is 100 percentage, the soil is totally dry. Okay, the totally dry. So that means the resistance is very high, and the value you are getting 1023. In case if you are getting 0, that means the uh, soil is very much having very much wet. Okay, it is full of water and it is wet, so that time you will get a 0. So you will not get 0, maybe near to some 10 ohms or 20 ohms, like that a small value of resistance will be shown here. Okay, so that percentage I am going to measure, and I am going to print it in the serial uh, port. And then after this is for moisture sensor. Then I need to go for a ultrasonic sensor for measuring the water level in the tank. So digital write trigger pin low. So this means first I am making it trigger pin low for 2 seconds. Then I make it trigger pin high to produce the ultrasonic signal, and I wait for 10 microseconds. For 10 microseconds, the ultrasonic signal will be emitted, and then again it will be stopped. Digital write trigger pin low. Okay, so for 10 seconds you have created one signal, ultrasonic signal. It will go and then it will see any object is there in the path. If any object is there in the path, it will reflect back and it will come back. When it is coming back, the receiver will receive the signal. Okay, so when the signal is received, that time the receiver will pin will go high state. So okay, so when echo pin is getting high, that means from on time to the echo pin getting high, until this how much time is taken, that will be measured and written in the duration variable. So this is a variable. So for time duration I use this duration. So how much time it taken for going to the object and it is coming back to the sensor, so that will be stored in the duration. So once you know the duration, you will multiply with this constant value 0.034 divided by 2. Okay, this is the speed of a light. Then we have speed of the sound. And then we once we get the distance, so that means we know how much distance is there between the sensor and water. Okay, so if the water is full, that means the distance will be very less. If the water is less, then the distance will be more. So once you get these two variables, I am going to write a logic for switch on and switch off the pump. So if distance is less than 30, so that means so if the distance is less than 30 and moisture is greater than 30, so this is my convenient numbers. This can be varied with respect to your values what you are getting. So this moisture content is 30 percentage I have taken. So if you want, you can keep 10 percentage or 20 percentage also. And here this distance I have taken 30 centimeter. So based on the size of tank you have, the centimeter can be different. Maybe you will get a 60 centimeter or 80 centimeter. So these numbers can be different. So when these two conditions are met, then what will happen? The motor or the pump will be on. And if any one of this condition is failed, then it will go off condition. Okay, this is a very simple application of a moisture sensor. This is a simple code. Now this is we have implemented this. So this is the picture of it. Okay, so we have implemented, we have one small tank here, and then we have a 12-volt battery here. Though the charging part and then solar is not shown here. Okay, so but it is there. Okay, so we have not shown here. So this one, this battery will be connected with the charge controller and solar panel. That's it. Okay, so we have the circuitries here and we have a pump here. Then we also put a small tub with a soil. So the soil moisture sensor is connected here. So let us see how it functions in this. So you can see a little closer view. So this is a pump, and we have a LCD to show all the datas, and we have a relay module here, and then I have a Arduino Uno here. You can see the values here. It also we also connected with a DHT11, which we have seen also in the previous active video, so that it will show the temperature and the humidity, everything. And here we have one flow sensor as well. Okay, when the motor is on and if when the water is not there, then the flow sensor will give the input to the Arduino so that it will switch off the pump. So that is again for a safety purpose. Okay, so this is the implementation of this project. Hope it is simple, and you can also do this project from your side, and the components are very much available in the Amazon, and then eBay and Banggood website. So these are the websites, a few websites where you can get all these materials, or it might be available even near to your home in some electrical and electronic shops. Okay, so if you have any doubts, please let me know, and let us come and meet with another interesting project next time. I'm going to make a little bigger project next time. I will, next video we will see some good interesting videos. If you have any topic which you want to cover or which you want to know, you let me know. I will make the video for that as well. Okay. Thank you so much.